Welcome to the physics program. Our lesson today is about Newton's first law of motion. While the students will benefit direct with this program, the teachers can use methodology of this lesson while teaching the same topic in their classrooms. The program is brought to you by the Ministry of Education and Vocational Training Zanzibar, funded by UNICEF. Production expertise produced by Kwarara Media Education Center, KMEC, under the supervision of Department of Teacher Education, DTE.
Good afternoon, students.
Good afternoon, teacher.
How are you today?
We are fine, and you?
I am fine. Today, we are going to learn verification of Newton's first law of motion. Okay?
Yes.
Before that, we have to answer a question trying to ask us about life experience. What happens to a bus passenger when the bus is about to start the motion and when the bus stops from motion? What happens to a bus passenger when a bus is about to start the motion and when it stops from the motion? Yes?
When the bus start move, the passenger move backward. When the bus stop move, the passenger move forward.
Okay, very good. Clap for him. As he have explained that when the bus is about to start moving, a passenger tends to move backwards. And when it stops from the motion, a passenger tends to move forward. This is the life experience. Okay?
Yes.
Now from that, we are going now to do experiment to verify Newton's first law of motion. I will give you the apparatus and you will follow instructions, okay?
Yes.
This is a glass, okay? This is a glass. And then you will have a coin and a card. So this is a card and a coin. This is a card and a coin. This is a card and a coin. Also, this is a card and a coin. Now, listen to procedures. Take that card and put on a glass. Take that card and put on a glass. Okay? Yes. Now take a coin, put on the card. Already?
Yes.
After that now, by using your finger, flip that card and see what happens. Go. Have you seen what happened?
Yes.
Have you seen what happened? Have you seen it?
Yes.
So what happens to the coin? What happens to the coin? Who can, yes?
The coin did not move.
The coin did not move. Very good. Clap for him. Where did it fall? Yes?
It falls inside of the glass.
It falls inside the glass. Very good. Clap for her. How about the card? How about the card? Yes?
The card the card move forward.
Very good. Clap for him. So, from our experiment, we have seen that as a card was flicked by our finger, the cone didn't move. Why? Because no external force acted on the coin. The external forces there acted on a card only. That's why the coin didn't move and falling inside of the beaker. Okay? Yes. Now we are going to do another experiment by using your own exercise book. Okay? Yes. Take your exercise book and put it on the desk. And leave it. Just observe it. What happens. Have you observed it?
Yes.
Okay. You have not asked to do that. Now, move it. What do you say about in the two cases? When you just put the book on your desk and then you weight it, and when you pushed it, what happens? What is the difference between them? Yes?
The first, the book is not moved. When we push, the book is moved.
Very good. Clap for her. If you put an exercise book on a desk and leave it, it will continue staying there. It will not move. But when you pull it or push it, it will move. Why? Why, when you leave it there, it does not move? Why? Because, yes?
Because when a body at rest, it will be continuous at the state of rest, and that of motion will be continuing in the motion unless the standard force act on it.
Very good. Clap for him. That the exercise book was just there because no external force was acting on it. But when you pushed it, it moved because there is external force moved. This means that we verify Newton's first law of motion, that which states that a body at rest will continue in a state of rest, and that in motion will continue in the motion in a straight line unless external force is acting on it. So we have seen that in both two experiments, we have seen that the coin did not move because there was no external force. The book, which was left on a desk, it was remaining there because no external force. That's why we have said that the two experiments verifying Newton's first law of motion. Are we together?
Yes.
Any question?
No question.
No questions. Now, describe how to verify Newton's first law of motion. Describe how to verify Newton's first law of motion. Who can describe? To describe is to explain that if I'm going to verify Newton's first law of motion, I will do this, 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 this. So is there anyone who can describe the verification of Newton's first law of motion from what we have learned? Yeah, someone to try. Suppose I come and I say, show me how you can verify Newton's first law of motion. You just show me, isn't it? So, my daughter, show me.
I can take a book and pull it. The Newton first law of motion is.
You can take a book and pull without putting anywhere. You just take a book, maybe it is in the air, you pull it. Oh, you put.
I pull and I take.
You pull where, when it is where?
On a desk.
So you say I can verify Newton's first law of motion by taking a book on air and I put it on a desk, I leave it, and when I pull it, I will see that when I leave it, it is not moving. And when I pull it, it moves. Okay? That is how you are supposed to answer, isn't it? The other experiment to verify?
Glass.
Mm-hmm.
Then I take a card, I just put on the glass. Then I take a coin on the card. So this experiment I'm going to do is Newton's first law of motion. So I just express. So I just see a coin did not move because there is no standard force act on the coin.
External.
Standard force.
External force.
The standard force act on a coin, and the card move forward.
Very good. Clap for him. That is one. Now, how Newton's first law of motion is applied in our day-to-day life? Yes?
In the bus.
In the bus? Passenger. Very good. Clap for him. He said in the bus, passenger. Who can explain more? How is it applied? Or you are the one who can explain? Yes, come up.
When a passenger are leaving a seat, the driver drive the car, the passenger can be backward.
Okay.
But the driver can stop the car, the passenger can be forward.
Move forward. Very good. Clap for him. That is how we can apply Newton's first law of motion in our day-to-day life. There are so many applications, but we can stick to today on that. Okay?
Yes.
Any question?
No question.
No question.
Of resting or uniform motion unless external force applied.
Very good. Clap for him. Newton's first law of motion states that a body at rest continue in its state of rest, and that in motion continue in that motion unless external force acts on it. Okay?
Yes.
Also, this law is known as the law of inertia. The law of
Inertia.
Yeah, it is also called the law of inertia. Inertia. Why? Because it is talking about a body at rest will continue to be in the state of rest, or that which is in motion will continue to be in that motion unless an external force is acting on it. Okay?
Yes.
Any question?
No question.
Have you understood?
Yes.
Thank you very much. Thank you for participating fully in this lesson. And I hope those who have watched our lesson have enjoyed. That is our end of our lesson for today. Thank you very much.